Hello students, today we're going to continue our work with functions, which we covered last quarter, but today we're going to evaluate functions that have two variables. So let's start off with just how do I write an expression like 3x plus 1 as a function. So we use function notation. We can use any letter. Our more common one is f and then g and h. So we can write it as f of x equals 3x plus 1, or we can use g of x equals 3x plus 1, or we can use any letter instead of f or g. So again, F, G, and H are the more common ones you will see, and so on, right? So how do I evaluate a function again? Again, just a quick recap. I think we did one in the do now. So again, plug in the number that's inside the parentheses. So in this case would be 3x plus 1 would be 3 times 7 plus 1. Again, you can mentally figure this out, but just visually to see it, this would be 21 plus 1 would be a total of 22. If I plugged in -2, I would have the following. -6 plus 1, which would give me -5. So this is how I evaluate a function. I just plug in the number that's inside the parentheses into the variable of the function. So substitute x for 7. So this is what I'm substituting right here. All right, let's go ahead and move on to the ones we're going to look at today, which are the new functions. How do I write an expression like 4x plus 10y as a function, where now, instead of just having one variable, I now have two variables? So when I write it in function notation, I have to make sure I indicate the value of each variable, and I have to make sure I indicate the correct order of how to substitute that value. So I would use something like f of x, y. Not just f of x, it'd be f of x and y. And in this case, the first number in the parenthesis would refer to x, and the second number would refer to y. So I have to be able to indicate an order to know which number substitutes where. So it's very important that you have an order. So for example, I would say f of x comma y equals 4x plus 10y, or g of x, or any other variable I want to use for the name of the function. So let's see how this actually works. So let's say we write 8t plus 10n as a function. My two variables would be t and n. Generally, just put them in the order you see them. They don't necessarily have to be in that order. So f of t comma n would be 8t plus 10n. Let's write the next one as a function. Let's call it g. So my variables are x and y, so I would put xy as a function. And 3x plus 2y. Let's go ahead and do the same thing with the next one. We're going to use s and t, and then put the expression for the function, and we're calling this one h. And the last one, let's call it k. And our variables are r and p, and we put 12r minus 13p. All right, now that we have our functions, we're going to actually evaluate using actual numbers for f, g, h, and k. All right, so if I say f of 2 comma 5, in this case, I mean I'm going to go ahead and take my function, which is the one at the top, this one right here, and this first number 2 represents the t, which is the first number. This number 5 would represent the second variable, and that's what I'm going to substitute into these equations for their variables t and n. So let's go ahead and see what that looks like. So f of 2 comma 5 is 8 times, and I'm going to plug in the number 2 and 5 in the respective locations. So the first number represents a t, and the second number in the parentheses represents the n. And then I just evaluate. 8 times 2 is 16. 10 times 5 is 50. We add it, we get 66, and I'm done with that one. All right, let's go ahead and look at b. So for b, we're going to have g of 2 comma 5. That means the first number 2 represents the x value. The second number 5 represents the y value. So I'm going to go ahead and plug in the 2 and the 5 in the respective locations and just evaluate 3 times 2 and 2 times 5. We have 6 plus 10, which gives me 16. These are pretty straightforward examples. We can make them way more complicated by adding more numbers. All right, this next one, I'm still doing now h of 2 comma 5. Where the 2 represents the first variable being s, and the second one represents the t, being the 5. So let's go ahead and substitute a 2 and a 5. We have -14 and -25, and we combine and get -39. And the last one, we're going to substitute k of 2, 5. And now we're going to make sure the R is a 2 because it's the first letter, and P is a 5, which is the second letter. So we're going to plug in a 2 and a 5 in their correct locations, multiply, 24 minus 65, and then combine, in this case subtract them, we get negative 41. All right, so that's kind of how functions work with evaluating when you have two variables. Just make sure you plug in the right letter in the right number into the correct variable. All right, next part is going to be just a recap of what is a function. Usually when we were previously looking at functions, we were looking at a graph and we were looking at the vertical line test. So let's say, for example, we had the following graph. We would say, yes, this is a function because it passes the vertical line test. It doesn't hit it more than once anywhere. So an example of something that is not a function would be something like the following. Let's say we have our grid. We have a picture as our function, and let's say I do the vertical line test here. Here, this would fail the vertical line test because it hits it once and twice, so that's not a function. But how do we know something is a function if we don't actually have an actual visual graph? Let's say they just give us a table. You can actually graph the table and figure it out that way, but what if you don't feel like graphing it? So usually, the fact that you have the vertical line test fail is when you have one input with two different outputs. What I mean by that is the following. Going back to the picture I had earlier, I'm just going to draw it real quick again. Here where the vertical line test failed, it hit it here and there. If I were to go ahead and get those coordinates, let's say it was the following here. This would be 2, 3, and this one would be 2, negative 2. So for the same input value, 2, we have two different output values, negative 2. That's where it's going to make the vertical line test fail. In this case, again, same input, different outputs. So that's what we're going to look at on our table. Is there a place where we have the same input and a different output value? So let's look at A. And is there a place where we have an input value where the output value is different? So here we're going to have negative 2. On the first table, we have negative 1, we have 1 and 2. These are all different input values, so there's no way to have the same input value and different output values. So in this one, we would say that this is a function. Let's look at the next one. So we have our input value is negative 5. I don't see another one, but I do see negative 1 once and negative 1 a second time. And notice that the output value on the right are not the same. These are different. So that's what makes it not be a function. Because if I were to graph them, it would fail the vertical line test. Let's look at the next one. I have my input value of negative 3, negative 1, different. 0 is not the same as either of the inputs, and 2, all the input values are different. So this is automatically a function. There's nowhere it's going to fail the vertical line test if I were to graph them. I want you to go ahead and try the next 3 on your own, and pause the video and come back to check your answer. Okay, so let's see what you got. So in the first one, is it a function? And the answer would be yes, it's a function. All the input values are distinct, all different, and there's no way to have the same input and different output. Let's look at the next one, negative 2, negative 1, positive 1, 2. Again, all of these are different. None of these are going to be the same, so it's automatically a function. Let's look at this last one. Let's look at our input values. We have the same input value twice, but our outputs are different. Again, this one wouldn't be not a function. So it's pretty straightforward. You're just looking for the input values being the same and do the output values match. If they don't, then it's not a function. All right, let's go ahead and move on to the last piece. Now, what if we were given the information as a set of points? Again, this is like a t-table, so you can think of this first one right here, A, as a t-table. So it's just not in t-table format. So this right here, you can think of it as being the following. You don't have to write this down. It's like 0, negative 1, 2, 3, 2, 6, 4, 2, and 6, 3. So you can think of it as that, and then look for the places where we have the not a function. So that's one way of seeing A. Now, if you don't want to write out the t-table, you can spend the time doing it. It's up to you. But you can just look for the input value. So that's what we're kind of focusing on, the input value. So in this case, I'm going to look at 0, at 2, at 2, at 4, and at 6. So I see here that these are the ones I'm going to box in because they have the same input but different output. So again, this is not a function. Let's look at the next one. Let's look at our input values 1, 2, 3, all different, 4, and 5. So this one right here would be a function. Let's look at the next one. We have -2, -1, 0, so far all different, 1 and 5. All of these are different. There's no matching ones, so there's no way it can not be a function. All right, let's look at the last one. We have -3, -1, +1 again. So again, we have that same input value. But if we look at our output values, -3 and 3, are those different? And the answer here is yes, they're different. So this right here is not a function because you have two outputs for the same input, and that would fail the vertical line test if you graphed them. All right, so that's a general idea. You should be able to tell me if something is a function from a graph, from a table, or from a list of points. And you should also be able to evaluate a function with one variable and two variables. Go ahead and start your practice, and good luck.